Hello. Okay, today we're going to be talking, this is an introduction for the trace tool application that manages, displays, and allows you to annotate the waveforms, i.e. traces produced by the ChipScope. So let's take a look first at the data that's typically produced by the ChipScope. So a ChipScope is a Xilinx IP that is loaded inside of the FPGA, and it's kind of like an oscilloscope. It allows you to record internal signals based on some trigger events. So, and at the end of the day, it produces this CSV file that looks, here I have one that I have generated an example, and it looks like that. So this is just a CSV file where each column is a trace, i.e. a waveform, and each column name is a name of the trace. Here's an example where I have 1, 2, 3, 4, 5 traces. Second row typically represents the radix, so that would be signed, unsigned, hexadecimal, binary data. And so the trace tool is capable of understanding that as well and correctly interpreting the numerical values in the rows below. And starting from following row, you actually see these are the data. So these are the actual waveforms. So in this case, I'm actually producing them artificially, and I have this little application that can regenerate this file. So let's start the trace tool application. It's by simply typing TT in a command line. So this opens the application window. Right now, nothing is really displayed. So first we have to create a project. We're gonna create a new project. We're gonna give it a name, example project. We're gonna pick the CSV file. And in our case, the CSV file is in documents, example data. Now we can actually see the traces. So at the bottom, you can see now the project that's now open. You see that this project is tracking the CSV file. So this CSV file is going to be regenerated by the ChipScope. And what will happen is that the trace tool actually creates the project directory where the content of this CSV file is copied over. It's actually copied in a binary, compact binary format, so not just a CSV. And there are a bunch of other files get copied in there as well. Well, not copied, but created, because this is not just the content of this CSV file, the traces, but other data. Remember, we're going to be annotating, recording this and that, applying various functions. So you have, now that project is open, you have several different traps, active traces, inactive traces. There are none of them right now. Views, again, none, and the project. So the project one allows you to see the project information, general project information. So the project name is example project. We can rename it. I'm not going to do this right now, but this tells you where the directory is, where the project is stored. Now, the other part, if you look here, if you look at the CSV file, you will see that there is no the time column. So whatever the sampling rate is in milliseconds or microseconds, it's not really shown here. But as a user, as application developer, application engineer running the ChipScope, you know what the sampling rate is. So by default, I'm just setting here the implied time step value of 1 millisecond, but we can actually change it. So we can change it to the, like that, let's say 0.123. Or more likely than not, your time step, you probably want to derive it from a sampling frequency. So this is going to be frequency of your, probably the FPGA at which it is running, the clock frequency of it. So for example, I can say 24 megahertz. And that's that will derive the time step dt. So You can also add a description here. This is just going to be recorded for you. This is so as you type, everything is saved automatically. You don't actually, there is no button to click save. So this data is stored in one of the files under this particular directory. Okay, now let's go to the active traces. So we can actually take a look. So here's an example of a relatively stupid trace where the trace just goes up, from 0 to whatever the incrementing number. Likewise, this. This is a little bit more interesting because this is a trigger. This is where the trigger was fired, right in the middle. And if you look here, you will see that at time, this is the time now in microseconds, as we correctly rescaled it here using this particular timestamp, time step. So if you look here, you will see that the 0 time is at the trigger time. So if the trigger column is present, then we will correctly interpret the time, and the time will be placed such that 0 times 0 is at the moment when the trigger is fired. So now let's take a look at this. So this is a little bit more interesting. So we have some sort of a waveform. Again, this is all fake, so generated by me. And then this is one, this is another one. And again, you can see that the time is set at 0. Now let's take a look what we can do with this things. So you can click on this icon here, there's trace config, and this will allow you to do quite a few things with this particular waveform. So you can change figure title. For example, you can say XYZ, and you can see that the title actually changes dynamically as you type. Say XYZ. We can also indicate to show legend. So, and it appears right there. You can pick the location for the legend, and that would be the best is some sort of an estimate that Matplotlib uses to find the location for the legend. But you can also change it to a very specific location like that. The x-axis label is shown right here. If we erase it, it disappears. If we say like that, we can say t or time. If the x-axis label is present, then the physical unit, in this case microsecond, is also present. And again, that's the physical unit is from the project configuration tab. Then likewise axis, the y-axis, let's set it to v of t. You can also apply linear transformations to this waveform. So for example, again, typically what happens is that the data in a CSV file, a trace is an integer, and it's a fraction of some from, if it's a voltage, maybe it's from 0 to 3.3, and it's some sort of a fraction of that, let's say 256 steps or what have you. So typically we'll need to rescale that, but that information is not really available as far as I can see in the CSV files. So you can say something like that. And again, as you type, this actually will be rescaled automatically for you. You can see like that. As you can see, the y-axis is getting changed as we type. You can also apply offset, and the function is obviously y prime equals the scaling factor times the original value plus the offset. Let's say we want to shift it upwards to 3. So now it is right there. So it's shifted upwards as a whole, and rescaled and shifted upwards. You can also indicate to show grid or not. Again, this is all updated dynamically. Now, a couple of things we can do here. Okay, beyond that. Now, typically your signal, well, very often your signal is going to be very noisy, as is the case in this particular case. Let's take a look at the noise level here. So that I artificially introduced. Let's say you want to apply some sort of a smoothing filter. So we call it an overlay filtered signal. So one way you can do is you can apply Savitsky Golay filter. And the window here is a percentage fraction of the percent of the total number of steps on the x-axis. So it could be a percentage, or it could be, if you say, oops, sorry, 100, like that. In this situation, it is going to be just the number of data points. So I can say, very large. Okay, well, that's obviously excessive. Or again, it could be a percentage, like for example, let's say 5%. So now if you look at that, you'll be able to see very well that that is indeed smoothed function. It is also, however, typically kind of like an oscilloscope. You probably want to use the low pass filter. So if we say low pass filter, we can say cutoff frequency. Here, this is where the time step, setting up the time step is actually important in a project file, in a project tab, because these cutoff frequencies are derived ultimately from, the in relation to that time step. So for example, I can say cutoff frequency 0.2. Well, that's pretty weird. How about 0.3? 3. Okay, that's probably reasonable. You can also say, how about 9? Okay, well, that's a little bit, you can see that that's a little bit noisier. So let's take a look at that. So this red line is the cutoff frequency at 0.9. We set it to 0.5. That's probably more reasonable, or even 0.4. Okay. And again, now if we take a look, we'll see that that's this red line, this overlay trace is overlaid over the existing trace, and it shows you the smooth version of that with the low pass filter applied. So what else can we do? So the other thing that you can do, you can compute several statistical functions. These are very basic. So you can say, what is the minimum value? What is a maximum value? The computed values for these functions appear in the label, in a legend. So if you say do not show legend, then you won't actually be able to see them, and they're not even getting computed. So in order to be able to see them, you have to enable see in label. Let's remove the X, remove the grid. So you can also do, I'm going to add all of them, range, mean value, this is your average, and standard deviation. And so you can see all of them in here. You can remove these functions by clicking on these crosses here, for example, like that. You can kind of change their order by, for example, let's say we want the mean to be at the end. So we can pick the mean again, and the mean gets added to the right, and then the removed from the front. So this way you can rearrange the values for this thing. So let's say we don't really care about standard deviation. And really care only about the range and the mean, which makes sense. So maybe we wanna do that. Then that makes a lot of sense. So that's the value from the average value, which is somewhere, as you can see, somewhere around here, the mean value, and then the range that's from the max minus mean. So, okay, so that is automatically saved and recorded. So anytime you click on this on this trace, you will see this information. The same thing obviously applicable to this particular trace. Let's apply low pass filter. There it is. Let's set it to make it a little more aggressive. 0.4. Okay. Okay. So what else we can do with this? So Now that we have this list of active traces, we have noticed that a trace name here is matches the trace name from the CSV file, these columns in there, sample and buffer, blah, blah, blah. So often these names are pretty long and not very representative. So we can actually sort of rename them. There's a concept of a trace name, which is the name as it appears for the trace in the CSV file, versus a trace label. At the beginning, when project is imported, the trace name and trace labels match, and the trace label is equals to the trace name. But we can rename this. We can say that foo, and we can rename this trace label, and then say XYZ. For any of these traces, you can click right mouse button to access the context menu. What else we can do? So we have several traces that we have in the file, but we don't really care about them. We want to have a clean view for the traces that we care about for your particular project. So one thing we can do, we can say mark traces inactive, and it will disappear from the tab of active traces. And then if you go to the inactive traces tab, you will see these traces in there. So there's nothing special about these tabs. This is just to allow you to organize them. You can still plot them, and everything works just like inactive traces. This is just a way to organize traces, the traces that you care about. So probably we don't necessarily care about triggers, so let's move that as an active. So that's for your project. This might be what you really care about. So what are the other things we can do? So as you can see here at the bottom, it shows the project name and the file that it is tracking. Remember, we're going to make a copy of this file, or we already made a copy of this file. And when we do that, notice that in the right lower corner, it shows traces version 1. Now, this is the tool that little gizmo that I wrote that regenerates the traces and makes them, apply some small minor difference on them. So if you go look here, file settings, you will see that there are several settings here. So that I believe reasonable behavior for this application. One is to automatically reopen last open project when application starts, and that's enabled. And the other one is to watch source files for the changes and notify user and prompt the user to reload the data. So if I am to regenerate this, the traces right now, so I'm going to click on the Gen 1, this CSV file changed, and this application trace tool noticed this change and prompts the user to reload changes from this file. So we say yes, and now notice that we have traces version number 2. Now if I click on this, now if you remember, this actually looked a little bit different. So in the right upper corner here of this window, you can see several drop-down boxes. So this actually tells you what version has been displayed. So this is the version that's been displayed, which is version number 2, which is the latest version. So when you click on it, when you double click on any of these traces, you always show in the latest version, whatever that is. Now, typically you will want to compare that with other versions. I mean, that's probably, the one before. So, and now you can actually see these different versions, and they're quite wildly different in this particular case. And maybe in your case, that won't actually be the case. So let's change the labels. We haven't changed labels for this one yet. And again, this is also some sort of VFT, possibly. The labels here will show you the, now when you're looking at the multiple traces, and we can disable it again and just show one, or, well, in this case, it's the same, but let's say we show 2 different ones. Whenever you're asking to show 2 different traces, it will actually show you the version. So you look in the green one is a version 1, the blue one is a version 2, etc. So yeah, let's take a look at this one. So let's take a look how this changed. And you can see here that, again, the green one is the previous version, and the blue is the new version, the latest version, and the statistical functions are computed accordingly for each one of them separately. So, okay, now let's regenerate a little bit more, and let's put it aside here. Let's regenerate another one. Say yes. So, okay, now there are a couple of things here. So if and you can see here the version now changed to 3. So again, if I click on this, I see changed version, the latest version, version number 3. I can also say plot latest and the previous version. This is probably a common thing that you want to do, just to compare them side by side immediately. You can actually see it like that. Yeah, this display may not necessarily be the most convenient one. You can also say plot specific versions of the trace. The traces version starts from 1, so we can actually say 1, 2, and 3. And it's going to plot you everything. In this case, all 3 of them. They don't look particularly useful, but there could be use cases where that is useful as well. So typically, again, I expect that you will be doing something like that, and you pick this and you say, I want to see the previous one, or I want to see like that, or like that. Well, this one is overlaid too much, so it's a little hard to see what's happening in there. The green one and blue. So, okay. So that's the way of tracking the versions. And the versions, again, every time the changes happens to a CSV file and you reloading it, then the data is copied over and you can review later any of the previous versions of these traces. So, okay. Now, let's take a look at something else. So what else we can do? So we have traces. So imagine that, let's change this. Imagine that this is current. Okay, we're gonna change the label and we're gonna say this is I1. Okay, let's use J1. Okay, so that's some sort of a current. Actually, let's rename this just so that we can imagine the workflow, how it would be. And this is maybe you're measuring current J2. So let's take a look at the scale of this. On this scale, so we probably should, so what is it, 0.01? Okay. Okay. So now imagine that these two particular traces are really that these two particular traces, J1 and J2, are currents. And you probably, it will not be uncommon when you want to add them together. And for that, we can actually create a synthetic trace. We can say create a derivative trace. So we're going to create a trace that's going to be, let's say, called the total current. And we're going to add word row. So we're going to add these two currents together. So we're going to pick this guy and we're going to pick this guy. Now, when I do that, okay, now I have this total current row, and that's a sum of these two. So this might not be that easy to see if that's the case. This. Oh yeah, and the reason for that is pretty simple, because the scale is way too off for this. Let's change the scale in here a little bit so that we can see. Okay, yeah, that will be much better. And you will see here, indeed, that is a sum of two traces. There is something from trace J1 and J2, and that's going to be your total current. So what are the other use cases that you have for these functions? Obvious, the other one would be you want to, one of these traces is going to be current and the other one is going to be voltage. So let's create another derivative trace, but let's imagine that J1 and J2, one is refers to current and the other one refers to voltage. So let's say power row. Again, we're gonna say row because we are adding the row traces, and we'll come back to clean the version of that. So you have several different functions. You can add traces, you can subtract. Maybe you're looking for the error of something. You can multiply, divide, and apply low-pass filter. I'm not entirely sure about use case for the divide, but the subtract would get you an error from maybe some synthetic trace. Multiplied makes sense for power, and add obviously makes sense for total current, or maybe total voltage as well, depending on your circuitry. So let's pick trace. So if you look here at the trace, by the way, so this is this trace picker. It allows you to, when you double click on any of these traces, it will be added. But you can also use this text field here to filter it. For example, as I type, it automatically filters. See, so often you will have many, many more traces. And so you may not necessarily want to scroll down, but you know that you're referring to current, so it's going to be J something. This search is case insensitive. So let's say I want to multiply J1, I want to multiply J2. One of them presumably being voltage, the other one is current. So now when we look at that, we see that it's voltage times. It's a little hard to see. It's a little hard to see the difference between them, but it obviously is there. So as you can see, it is not identical. And we can actually overlay them and see them side by side. Now, just as these the synthetic traces refer to, we'll be able to access the versions. I remember synthetic trace is a sum or multiplication, multiple, or some sort of a function from the source traces. And the source traces we refer to version 3, 2, 1, etc., etc. So for example, I can see like that. And so this is that synthetic trace of power. There is the trace J1 times J2 for version 1. If you look at version 2, there you go. So now the what if we, so remember that we call it row because we are simply adding two row, I mean, in this case, multiplying two row traces, and there's no filtering done yet. So we can, of course, apply here low pass filter like that. And, maybe this is something what you want. Because one of the aspects here is that if we, for example, ask, maybe you don't necessarily want to see all the noisy signal, you want that signal to be filtered out as a whole. So for example, if I apply some sort of a function like, let's say, range, I show the legend, there's your range. So this range actually refers to the original raw signal. So it's going to be somewhere from here, this max value minus the mean value on the blue. But maybe you really want to see the delta, this for example, the range of the values applied to the filtered signal. And maybe you don't even want to see necessarily the raw signal. So how can we do that? So one way we can do that is that we can create a synthetic trace. We can create a derivative trace. Let's say J1 at 0.4 megahertz. It's going to be the name. We're going to apply low pass filter. We're going to pick the trace J1, and we're going to pick the frequency here of 0.4 megahertz. You have to supply here physical unit as well. Okay, so now we have this trace, and if we look at this trace, you will see, oh, this is the cleaner version of that, and that's the one that here is overlay, and here is a separate trace in its own right. So Now in this trace, if I ask to show me, for example, the range, and I show legend, you will see that there's a slightly different value from, let's take a look at the range here. There you go. So you can see that the range here in the original one is applied to the blue, to the raw signal, and the overlay has no effect on the statistical computation of the statistical value. But here it's applied to this filtered version of the trace. So now, okay, so we have this manufactured version where we filter it out. Now we're going to create another one of similar nature, J2 0.4 megahertz. And this is going to be also low pass filter. We're going to get this guy, J2, and 0.4 megahertz. Okay, now we have the synthetic traces, slightly filtered traces for this in. So there you go. And of course, this one you can also see. You can see any of the previous versions that are filtered according to this filter of 0.4 megahertz. So there you go. Okay, now we can create another trace. We can create another derivative trace. We'll say power. I'll use word clean. And that's going to be multiple of two traces. Now we're going to use these other manufactured traces, the derivative traces. And now you can see that filtering already makes some sense now that we are starting to accumulate traces in that list. So, okay, now if you look at that, oh, that's our power. And then if you look at this, you'll see that again, this now new power is right here, and that's the one where it's constructed from the signals already filtered prior to the construction. And then we're gonna do range, show legend. And you can see here that the delta, that the range is different, because indeed here the range is for the clean signal, and here the range is for the power computed from the raw signal. So, okay. So that's how you can also subtract and divide. Divide can be a little weird when you have a division by 0, so you might not be able to construct certain traces. There will be an error displayed. So okay, and then like any other trace, these traces can be moved to inactive. So for example, I can say mark as inactive, and it disappears, and it's here. Again, nothing special about this trace. So let's move it back. Mark as active. So these traces can be deleted. You can say delete trace. It prompts you to delete a trace. Let's do so in one example. And the other thing that you can do is you can actually change the. Well, let's take a look at this one, for example. If I change the definition of this trace, so now I can modify the function that, how this derivative trace has been constructed. I can change the function. So let's say I want to change it from 0.4 to 0.3. Actually, we can take a look at these first and then compare them side by side. So now we're going to change the definition of this to, let's say, 0.3. And this, we probably want to change the label then as well. And this one we're going to change to 0.7. So this will be a noticeable difference. Now this power clean is now being affected as well. So if you actually, it should be affected, but might not necessarily be the case because of the caching. Or maybe this change wasn't really drastic enough for this. But in any case, so the point is that you can change the definition of your functions. You can say, for example, I can subtract them. That's going to be a little strange. So let's say this one minus, well, actually, let's take a look at, let's pick the first trace to be J1 and the second trace to be J1 filtered. What is the difference between them? Well, it's hard to explain, hard to understand what it is, but obviously in your case, there will be use cases where you want to be able to subtract, and again, it shows you probably some sort of an error, and this is the difference between the between these two traces. So now, what else we can do? So we can look at individual traces. We can apply filters. We can change various configuration parameters to how to display them, compute statistical functions. But let's say you want to be able to display multiple traces at the same time on a screen. And for that, we can create what's called a view. So we are going to create a view. Go File, Create View. And let's create a view v1. So we're going to have a view consisting from, let's say, 2 rows and 1 column. So when you come to do this, now you have this configuration for the view. You have a name. So this is your name, and that's what appears in here at the top. And at the beginning, it matches the name of the view that you're creating, but obviously you can my view. You can change what you want. Now these elements here that highlighted when you move your mouse refer to the subplots and what is going to be displayed on this subplot. So if I click on the first one, I'm going to say this is subplot at row 0, column 0. So we're going to add traces here. So for example, what do we have? We have, let's say, J1. And then let's take a look. We add to the second one, to the subplot below. We're gonna add this one. When I click on this, now you can see these two different traces. This is the row. This is the filtered one. You can add other elements here. You can, let's say, we add this. Now you can see that's the J2. We can say that we want to see labels. We want to show, first you have to indicate that you want to actually show legend for the scene. And then that's really still not enough, because you want to be able to, you need to indicate where legend's location is to be. So if you say like this, then the legends will be shown right here. Notice the important part here that we didn't really configure anything special, but for this blue line, for J1, we are showing statistical function of the range being 2.9. So where that's coming from? So that is actually coming from the fact that if you go to individual trace for J1, this one, that we have this statistical function range here. So let's do this one as well. When we click on this, now you will see that we are displaying the range and the mean value for this for J1 0.4 megahertz trace. So those statistical values, statistical functions for particular trace you define in individual trace, and then you indicate here by saying that you want to show the legend, and that will show. So if we remove, for example, this one, maybe we don't care about this, that disappears. What else we can do? Just like anything else, we can indicate show grid, and for this subplot or not. Some of the behavior here is automatic, some is not. So for example, time, you probably want to show below, but it makes little sense to show the below this plot. one of the things that you can see here that they actually synchronize the x-axis. So if I, for example, if I zoom in here, you will see that the zoom happens in all subplots because the time the x-axis is connected. The zoom is connected on x-axis. So what else we can do? So let's say we say show overlay. So remember that if I say, for example, for this one, this is the row trace, and I say show overlay, what will happen is that this actually shows overlay trace. Now, again, this, just like statistical functions, this overlay is defined in the J1 in the J1 trace itself. And by the way, here you can see now that these are the traces that are to be displayed. So now if you go back to the J1 and we look here, so if we, this overlay will be affected here. So for example, if I remove the overlay and then I come here, then this overlay is no longer present. Even so, it says here show overlay. So basically it means that show overlay if any. Now, and these are the usual scenes. So the y-axis label, maybe it's V or current, and right axis, I'll show you where that's actually coming from. So now imagine that we have, so let's take a look at the J2. So a J2 trace is imagine that we have these two traces, J1 and J2, that are wildly different scales. If we plot all of them at the same time on the same y-axis, then one of them might not be quite visible. So let's try doing that, exactly that. So let's change the scaling factor here and just make it like that. So now they are wildly different, the scales. And when we look, you will see that indeed the J2, this is our derivative one, filtered out and all. And then this, the blue trace J1 is barely visible, that something is changing in there. So what can we do? We can actually say that we want to show this J1 on the left axis and J2 on the right axis. When we see that, you will see that one of them on the left axis and the other one on the right axis. So it's a little hard to see right now what actually happened because the color is set for auto, and the auto is actually per the axis. So if I say, for example, this one is red, J1, so this allows you to explicitly control the color of the plots. And this one is, for example, green. Now we can see, okay, the J2 is here, and J2 is on which axis? J2 is on the right axis. So I'm going to say that J2, and this is going to be J1. So now you can see this labels present here as well. So so what is the other aspect here? So remember that when you're looking at individual trace, you can actually see the various versions, 1, 2, 3, etc. But when we're looking at the view, there doesn't seem to be a way to control that. So now if you come here and then to view config, you'll see that we can actually do something like that. So notice that for any particular trace, there is a text field here that indicates version. Now traces are versioned from 1, 2, 3, starting from 1, but you can also indicate a negative value. What a negative value refers to is counting from the end of the traces. So if the latest version of trace is number 3, then version -1 will indicate version 3. If you have 10 versions, then -1 will indicate version number 10. So let's say I want to see, again, this is J1, and I want to do this one version, let's say 1, and this one I want to do version, so the last one, the first and the last one. Let's take a look what it looks like. So it actually shows you here that we're looking at version 1 and -1. And again, you can see here that these versions appear there. Let's show legends for these guys. We will see that. And again, the statistical functions will be indicated here as they're defined for each individual trace separately. So the views do not allow you to control what version you're looking at dynamically. So you kind of have to define what these versions are. Also, if you're starting from a negative value for the version number, that will refer to, again, that's somewhat dynamic because that refers to the version from the last one, counting from the last version. So the other small thing, so for each one of these where available, you can see this little question mark sign, and this will actually show you some help, hopefully helpful. And likewise that exists for the for this. If you look here, there's a help here indicating what you're supposed to enter and what it means. This is not present everywhere yet, but it will be. So the windows, by the way, when you open them, they're all present here, so you can actually go look them up. We opened a bunch of windows and they are hiding somewhere. There they are. So you can close them, find them, and close them as you see fit. So yeah, so you can explicitly request to reload trace from the source. Again, this will actually do nothing right now because we don't have any new traces. And normally you don't really won't be doing it because you are watching the CSV file for changes. So in the future, we can actually pick the future expansion of that will allow you to pick different sources, not necessarily CSV file, other functionality where you can do other things with the traces. So for example, the Fourier transformation is not available right now. So you're always looking, when you're looking at the trace here, you're always looking at a trace in time. Yeah, but there will be a functionality where you say, okay, I want to create a derivative trace. The derivative trace is to be a function being applied, would be a Fourier transformation. So, and many others where you can, you'll be able to annotate and say, I want to put, a label here on the screen, or similar to oscilloscope behavior, vertical and horizontal cursors, but that's not available right now. It will be available in the future versions. So that is all.